February 2020. Berlin. An artist walks down an almost empty street, pulling a little red wagon. Inside the wagon, 99 phones. Every one of them running Google Maps. Before long, Maps paints that street dark red. A traffic jam that doesn't exist. Navigation starts steering real drivers away. The street stays empty. 99 phones just equal the traffic jam. Why did that work? To answer that, we have to follow the phones. So how does Google Maps know where the traffic is? Here's the secret. There are no magic sensors buried in the asphalt. Well, mostly. The traffic layer is made of us. Every phone driving around with Maps open acts as a probe. A tiny, anonymous reporter. And it phones home with just two things: where it is and how fast it's moving. Take one car. Yours. As you drive, your phone quietly notes its location. Every few seconds, ping. Each ping is a dot on the map, with a clock time attached. 2 pings, and it's just math. Distance between the dots, divided by the time between them. That's your speed. Congratulations, your phone just measured the road. And you didn't do a thing. Now zoom out, because you're not alone. Google chops every road into short segments. Think of one block at a time. Thousands of probes roll through each segment, and each one reports its speed. Roughly, the server gathers those reports, tosses the weird ones, and averages the rest. Fast average. The segment's green. Slowing down. Amber. Crawling. Red. Do that for every segment, everywhere, again and again. That's the traffic map. Back to Berlin. Now the wagon makes sense. To the server, a phone is a phone. 99 phones crawling down one street look exactly like 99 cars stuck in a jam. Slow speeds. One segment. Lots of reports. The average collapses, and the street turns red. That's crowdsourcing's blind spot. It measures phones, not cars. Google took it in good humor and says it's gotten better at filtering tricks like this. But the lesson stands. The crowd is the sensor. Here's roughly what one report looks like when it lands. A road segment. A speed. A timestamp. And who sent it? Stripped. The reports are anonymized, and they only matter in bulk, averaged with everyone else's. Maps needs the crowd, not you specifically. If you turn location sharing off, the map barely notices. One probe more or less changes nothing. 1,000. That's a traffic jam. There's a catch with live data. It tells you about right now. But you don't need right now. That highway is 20 minutes ahead of you. So Maps blends in history. How this exact road usually flows at this hour, on this day of the week. Machine learning ties it together. Google and DeepMind built graph neural networks that predict traffic for when you'll actually arrive. In some cities, arrival estimates got up to 50% more accurate. Now the payoff. You're driving, and a segment ahead of you turns red. Under the hood, Maps sees the road network as a graph. Every segment is an edge. Every edge has a cost, the time to cross it. Red means that cost just jumped. So the router reruns the math on your trip. If the parallel street is now cheaper, your blue line hops over. That's a reroute. Not magic. Just a graph, repriced. Zoom all the way out. Over 1 billion people use Google Maps every month. Every trip feeds the system that guides the next one. Countless road segments, rescored over and over, all day long. No exotic hardware. No citywide sensor grid. Just many tiny speed reports, aggregated fast. That's the whole design. So, one more time, end to end. Your phone pings its location as you drive. Pings become speeds. Speeds pour into road segments and get averaged. Green, amber, red. History plus machine learning predicts the road ahead. Red edges get expensive, and your route gets repriced mid-drive. And it works because millions of us are the sensor. Anonymous, and in bulk. One artist. 99 phones. One fake traffic jam, and now you know exactly why it worked. There's a system like this behind every app you touch. Next up, you tap your card, and it clears in about 2 seconds. How? Subscribe, and let's crack it open.